So that's the conceptual idea. Thank you, Bob. High five. Now let's go back to our definitions. I do have a few more definitions to share with you. There's just a couple more ways that we can describe slope using language. We've already talked about it's a measure of steepness, that it's a rate of change. Slope is also represented by the letter M. As you may have noticed when we were taking these notes, it gets very tedious to write the word slope all the time. It's just a lot of letters. So mathematicians have decided to shorthand slope as M. Why did they pick M and not S, you ask? We don't know. Slope doesn't have M anywhere in it, but that's the letter we use to represent it, so M is just going to be our shorthand so that we don't have to write the word slope anymore. Okay? M represents slope. Now this M can be represented the following 5 different ways. Okay, hopefully you've heard some of these before. It can be rise over run. Notice all of these fractions mean the same exact thing. Rise over run, or change in y over change in x. So that rise is really a change in the y-axis. Your y-axis is your up and down. Over a change in the x. Your run is your change in x. How far to the right are we going? Remember, we read left to right. This also represented by y2 minus y1 over x2 minus x1. That's where did we end up at y minus where we started at y. Where did we end up in x minus where we started in x. Okay, change in y over change in x. That's the formal way to write it out. This representation shows that it's a vertical change. It's how far are we going up and down over left to right. Notice there's only one arrow because we only run to the right. Run to the right. Run to the right. Do you hear that? Double R's. Never mind the fact that rise also starts with R. We only run to the right. So this is going to be up for positive and down for negative, just like we talked about with our uphill and downhill. But our run is always going to be a positive number to the right. We're always going to read it left to right. The top represents a vertical change and the bottom represents a horizontal change. Okay, so slope is just a measure of steepness, and this is the fraction, the change in x, the rate of change in y over change in x. That's how we represent what slope is. And it just describes how steep a line is. Is it super steep, a big number? Is it not very steep, it's a fraction that's less than 1? Is it positive going uphill or negative going downhill? So let's look at an actual example of a line on a coordinate plane. We have this beautiful line here. So you're going to need to take a minute, perhaps pause, to copy this graph. You're going to have to make a coordinate system and check out where those points are. Slope is represented by rise over run, the vertical change over the horizontal change. Change in y over change in x. And again, we read left to right. So we start with this point that's very clearly marked on the left, and we're going to this point that's very clearly marked on the right. That's our path. We start with our rise. So from this point, how far do I need to go up in order to be level with the other point that I care about? Notice we're not trying to be level with the origin or the end of the arrow. We're actually looking for another specific point. So we're trying to rise far enough to be level with the other point that we've identified. So it turns out the rise here in green is 1, 2, 3, 4 units. And we had to go up. So remember, the rise could be positive for up or negative for down. So if you're rising, it's positive. If you're falling, it's negative. And that's going to be 4 units. 1, 2, 3, 4. 4 units positive because we had to go up. Notice my arrow was going up. And then we do our run, which is always to the right. That's why this arrow was only to the right in the last page. To the right, we have to go 1, 2, 3, 4, 5, 6. So 6 places to the right. And that run is always going to be a positive number. Always going to be positive. So again, M represents our slope because we don't want to write the word slope. It takes too long. We don't have time for that. Slope is rise over run. I put my run in red. Run, red, to the right. You hear all the R's? So our rise ended up being a positive 4 over our run, which ended up being a 6, Our run is always positive. Now this fraction, 4 over 6, you can actually reduce a little bit. 6 does not fit inside of 4, but 2 fits inside of both. So I can actually reduce this fraction by dividing the top by 2, giving me 2, and the bottom by 2, giving me 3. So 4/6 is the same as 2/3. Notice I went up 4 over 6 on here. I could have just gone up 2 over 3, and that puts me at another point on the graph as well. So it turns out going up 2 over 3 gets me to the next nice intersection. And I could go up 2 over 3, up 2 over 3 all day. Okay, and I would still stay on the same line. So that m, that rise over run, 4 over 6, is the same thing as 2 over 3. So the slope of this line is 2 over 3. Now another way to find that, let's say I didn't give you a beautiful graph that we could just count the tick marks, count the spaces rise over run. Perhaps I only gave you those 2 points, and I didn't tell you or show you the rest of the graph. Instead of having to graph it yourself, we could just write down what those 2 points are. In this case, this left point is 1, 2, 3, so -3, comma, -2. That's our leftmost point. Our rightmost point is 3, 2. Notice when we write the coordinates of a point, it goes x, comma, y. X is to the right and left, and then y is up and down. Slope is the exact opposite. For slope, we rise, we do the y, the change in y, over the run, which is the change in x. Y over x, which is different than x and then y. So please don't confuse the way that you write points just because rise over run is backwards. Okay? Rise over run goes y over x, but points still go x, comma, y alphabetically. So pay attention to the fact that those two are backwards. Now, if we were just looking at these points and we didn't want to graph them on a coordinate plane, we would use our slope formula, and that was definition number 6 that we gave in the previous slide. Now, this slope formula is something you're going to have to memorize. So m equals y2 minus y1 over x2 minus x1. You're going to need to know that guy. That's very important. Really, both of these two guys are going to be your key definitions of what slope is. The other words are going to use to get the concept into your head, but these two guys are going to be what you're going to use practically to get the number for the slope. So in order to do this, we need to label some things. We don't know what y2 and y1 are yet. So let's keep with my color theme. Let's keep my rise in green. So green is my vertical shift. So I've got 2 y's here, 2 green y's. We need to pick one to be the first point and one to be the second point. Now, even though we go left to right when we're looking at a graph, it doesn't actually matter which one I pick to be my starting point and my second point. So I can choose either one. I like to do them in the order they're written. So this is point number 1, this is point number 2. Just because that makes sense to me. Again, America, left to right, 1 and 2. So this will be y1 and this will be y2. I just need a way to differentiate those 2 y's, so that's why we use the little subscript. This is the y of point 1, this is the y of point 2. I'll use my red to denote my x's. Again, I have 2 x's, and it's kind of confusing if I just write x and x, so I'm going to add a little subscript to say this is my x from point 1, and this is my x from point 2. So that's where the subscripts come from. So the first thing you're going to do is label your points, x1, y1, x2, y2, and then we can just substitute it right into that formula. Now remember, whenever you substitute, you need to substitute into parentheses so that you don't lose your negative signs. So what is y2? Well, it happens to be 2 here. So I'm going to put that 2 in parentheses. Then I'm supposed to subtract, so a minus sign in the middle. Substituting again, my y1 number happens to be -2. Over, now I'm looking at my x's, they're in red. My x2 number I'm going to substitute in is 3. Minus, my x1 number is -3. That way I can clearly see my negative signs. I can clearly see that I actually have 2 in a row here. So I'm going to move down to the next line. Slide our fraction over here. This double negative business, when we subtract a negative, it turns into a big plus sign. So this is going to turn into 2 plus 2 on the top. And on the bottom, this minus a negative 3 is going to turn into a plus as well. So 3 plus 3 on the bottom. Notice that that gives us 2 plus 2, which is 4 on top. And 3 plus 3, which is 6 on the bottom. Hey, that's exactly what we got when we counted it out. So if you don't have the graph and you need to do it by hand, you're going to get the same exact thing by using this formula. These two formulas are counting the same thing. This just applies more when we have the graph, and this applies more when we have the 2 points written out. 4/6 reduces just like our other fraction did into a fraction. They're both divisible by 2, so 4 divided by 2 is 2, 6 divided by 2 is 3. So notice we got 2/3 as the slope of this line, both. We got positive 2/3 because this line is going uphill, and we got positive numbers on both. Oh no, my 3's in green. So sorry, the 3 should be in red. There we go.